I'm here to represent the National Partnership for Climate Projections, or NPCP, which some of you may not have heard of. Some of you are in it, and that's great. But if you haven't heard of it, I would explain that a little bit as we go through. But just to note, there's a really important couple of people in the room from the NPCP. That's Ramona, is the manager and leader of Working Group 3, and Ben Evans in Working Group 2, and I'm from Working Group 1. And at the moment, downscaling, or taking information and making it locally relevant, is a really important part of producing climate projections, because obviously people want to know about regional climate change. And that generally means taking something that is coarse resolution until we get those kilometre scale global projections. Downscaling is a part of producing projections that are locally relevant. So just a general comment about CMIP through a value chain to decision making is now recognised as an almost operational kind of thing, and that is recognised by now having a CMIP office and having this core, or sometimes also called a service hub, to the CMIP7 structure. So the research ones, but then there's that core which is kind of delivering the things that are most used, but also the things that are going to be most used towards decision makers. Of course, climate services goes beyond just using models. It means assessing multiple lines of evidence and observations and so on, but models are a central tool, so modelling is a big focus of climate services in general. And just to kind of make it more clear, is downscaling means making projections more locally relevant. That's not necessarily using dynamical downscaling or regional climate models. That can be done in multiple ways. Simple scaling or delta scaling has its place and it can be very useful. Statistical modelling is very useful, and the kind of very rapidly expanding area of machine learning is kind of a big area now coming in. But dynamical downscaling, using regional climate models to make projections more locally relevant, is a really important technology used right now. And there's recognised added value in running those regional models that then adds to that path to impact for regional applications. There's various important programs running right now at the state and territory level, as well as federally, looking at producing regional climate information. And just as an example, I could have picked anything, but there's statements like this in state, territory, federal, guidelines, documentation, saying that they will use the latest information. And that kind of implies, either directly or implicitly, that they will survey the latest set of climate models. They will use technologies that are available now, such as downscaling, to get that best picture of climate change in the area for when they produce an assessment. So downscaling can give you a more resolved depiction of the current climate. It can also give you new information about the climate change signal into the future. And when you get both of those together, that's evidence that it's doing something really useful and important. And there's a concept that we kind of developed called realised added value. That was a paper led by Giovanni Di Virgilio there, which I think is really useful. And the map at the top there kind of shows where that was identified from existing downscaling runs. And it's kind of where you would expect. So over mountain ranges, islands like Tasmania, coastlines and so on. It's doing something, a better depiction of the current climate and new information about climate change. And there's several cases of this that have been documented and published, including enhanced warming at high altitude because of snow feedbacks, but other factors as well. Potentially greater drying over the Alps in the cool season compared to global climate models because of the effect of topography, important effects over Tasmania and differences between East and West Tasmania that have been identified by regional climate modelling, and really important effects on rainfall and rainfall extremes up the eastern seaboard through from New South Wales and Queensland and others. Of course, downscaling only can use what it's given, so it's dependent on what's given to it by the global climate models. It can't overcome the errors that go into it, so it plays a really important part in the chain, but it's part of a chain. I'll skip over that. So the National Partnership for Climate Projections was a consortium and a collaboration to come together to help it cooperate and lift everyone's capabilities and leverage opportunities for intercomparison, coordination and knowledge sharing between producing climate projections from the level of technical through to assessing user needs and delivering communication products. A big focus of the current generation projections is a special focus on intercomparing and helping coordinate various regional climate modelling efforts so that we can all reach our common goals better. But we're also looking towards the future about what's the next generation of projection, what that looks like, how we can prepare for it. As I mentioned, there's 3 working groups and those are listed there, and I've mentioned the people involved. But I should make a special mention that there's the roadmap, which is being sent to the printer right now.
Which is due for publication very shortly.
Yes.
You may have heard this before. It's real. So publication's been approved. So thanks to everyone for their patience.
And that involved the input and contribution from all of the partners, which are all listed there, which includes federal, but also state and territory organisations. And the process has been very open and very collaborative, and I hope everyone has felt the opportunity to be involved if they want to, and to contribute.
Can I just say one thing?
Yeah.
On that diagram, you've promoted me a bit, which is great, but I'm acting as the secretary, and that's what, you know, Leanne's team will continue to do in DQ. And Catherine Smith will actually be the chair of the overall partnership going forward. So,
Okay.
yeah. But that's a very important person in the room.
That's great. Thanks, Ramona. So just a quick note on the current generation. So an ensemble to underpin services for all. So what we'll end up with is a multi-scenario, multi-model ensemble with partners from Queensland, with Joseph's here, New South Wales, Western Australia, Tasmania, the Australian Climate Service, and so on, to produce a model ensemble which is compliant with the Codex guidelines. It focuses on the highest priority SSPs identified by Codex, and we'll end up with not only each regional modelling program, which is useful in and of itself, but the ability to compare between them in kind of a sparse matrix kind of configuration at higher resolution, and so that you can understand the effect of different techniques or different models to get to high resolution, as well as the different models used as input and so on. And if you can read the text, ACCESS CM2 and ACCESS ESM 1.5 were chosen for downscaling, at least one of them, by every single program. 3 separate and pretty independent model selection exercises arrived at those choices, and that was on merit. That wasn't a favouritism thing because it's Australia's model. They were just evaluated very well, filled out an important part of the potential climate change projection space, and so were important to include in that model selection exercise. Then, of course, this ensemble can be complemented with other lines of evidence, including CMIP7 itself, including large ensembles. Having the ACCESS 40-member ensemble is extremely useful here to put those ensemble members used in a wider context. And then various programs of convective permitting modelling for some targeted areas marked by coloured boxes there. So what do projections generally want out of CMIP? This is my opinion, so others can disagree. First and foremost, just a practical thing, all the data required for downstream analysis and modelling. So for example, all the variables that you can run tropical cyclone tracking and 100 other things. But first and foremost, the scientific thing we want is a model that evaluates well in the current climate, past trends, paleoclimate, especially for Australia and especially for processes like ENSO. That's the number one. But we also then want really a balanced ensemble. So having this hot model problem from CMIP6 was a bit of a pain. Having more models with high climate sensitivity than over-representation was a problem. Independence is a problem. So models are not all independent from each other. That's a problem. What we'd really like would be the minimum number of models, the largest ensemble size from each model, and the highest resolution practical. That would make our job easier and would be easier to deal with. But you know, we can all dream, I guess. And we would really like a model ensemble that can explore the full probability space, including the tails of possibilities, including the very hot model end, but all other aspects of the uncertainty space in a kind of balanced way. We would like them to run useful experiments, plausible scenarios, perhaps the next generation have more on carbon removal, zero emissions, CDR, maybe those kind of new questions can be addressed more in the next generation. Really need and improvement would be great on data and code workflows to make the kind of whole process and the turning the handle on all this data processing easier. And then now and more into the future, the ability to use it in conjunction with other tools to generate knowledge. So that includes downscaling, but it also includes emulators, machine learning, and so on. Really quick points, because I've given the one point. So what do regional climate modelers want? They need the required data sets. Not all CMIP6 models did it. Hardly any did, which was a real pain. Information so that we can select models and design ensembles more easily, and some technical issues like high resolution land use, urban inputs, and data storage and dissemination. And so what do projections want out of ACCESS model? Again, a world-class model. Large ensembles would be great. Addressing the questions of highest interest to users, including more on carbon. While it may not necessarily be selected for downscaling next time, we would expect it to be very competitive, and so no reason why it wouldn't be selected in any kind of subsetting or ensemble generation in CMIP7. And just, again, to make that point, the ability to use it in conjunction with other tools. So you can use regional climate models to train machine learning. We can use the outcomes from kilometre scale models to test fundamental issues compared to CMIP. We can use large ensembles in conjunction with other models to get a fuller picture. And that's why we think something like NPCP is really important, because this means bringing different people together, people who use regional climate models, people who use machine learning, people who are generating CMIP to kind of come together. But that's me, but maybe Ben or Ramona would like to add.